So we're just going to go through this basic data acquisition setup using a while loop. So if we right mouse click on the functions palette and select the while loop from the structures palette, drag that into the workspace, the while loop will execute until this control here is actioned on. So what we want to do is to right mouse click and create that control here, so that when we press stop on the front panel, the while loop will stop. But up till then, it will continue to collect data. Inside the while loop, we're going to create our acquisition. And that's going to be this Express VI, which is the DAQ assistant. You can find it through the Express palette on the functions, and then it's in the inputs box there. But it's the DAQ assistant. You could also search for it. We're going to drop the DAQ assistant directly into the while loop, and we're going to select Acquire Signals. Looking for an analog input channel and its voltage that we want to measure, and it's going to be analog input channel 0 here. So once we've selected the correct input channel, we can configure that channel in this kind of wizard. Now this time round, we're going to collect just one data point for each execution of the while loop, and so we'll want the one sample on demand down here in the acquisition mode. Later on, we're going to collect n samples, but just for the moment, keep this set at one sample on demand. Check that the range is from -10 to 10 volts, and that the terminal configuration is differential. We measure the difference between the positive and negative inputs to the terminal. Okay, so this should be set now, and we can press OK, and the Express VI will kind of deploy onto the workspace here. What we're going to then want to do, and this VI is capable of outputting arrays of data, so it's automatically set up that the output here will have multiple numbers in it, an array, and we only want one number because we've told the VI to only collect one number. So the first thing that we're going to have to do is to actually take just the first number in this array. That's the only one with anything in it. So we select this index array here and wire our data into the index. So you'll see that also, before this index array VI is able to execute, it's had to convert the data type from the special signal data that's being outputted from the DAQ assistant into just a straightforward double precision number here, indicated by the red thick line. Okay, so what we want to do for each execution of the while loop is actually collect together these values in a new array. So we're going to use the insert into array icon here, which I found here from the array palette, insert into array. And what we want to do is to insert into the same array. So each time the while loop executes, we insert a new value into the same array. And to do that, we'll need a shift register. So that the data being, well, the array, we wire this up, and then wire our number that we're going to input into the array as the element to insert. Each time that the loop executes, a new number will be added to the same array, and that's the output of the shift register at the end of the execution of each iteration of the while loop becomes the input to the next iteration. We'll also want to create a array constant as the starting point for this execution here. And the final thing we want to do, if we right click here, is create an indicator which will get updated each time the loop executes. So if we go to the front panel, we'll see this indicator as an array of data, and we'll want to right click on it and replace the array with a graphical waveform graph. And now if we run the VI, it's going to collect this data every so often. But what you'll see is that as more and more data is present within the array and presented on the graph, the acquisition rate actually starts to slow down. So while this is one way to check the operation of your acquisition program, it isn't a particularly effective way of collecting data. In the next blocks, we'll go on and look at other ways to do this.